Assalamu alaikum dear students. Today we are going to discuss another method of integration, that is integration by parts. You know that if we have two functions f and g, then the differentiation of their product, that is d by dx of fx into g of x, is given by the product rule of differentiation, which is their differentiation is fx into g dash x plus f dash x into g of x. So using this indefinite integral definition of indefinite integral, which implies that this function actually fx gx equals to integral of this fx into g dash x plus integral f dash of x into g of x. Arrange the terms, so we simply get integral fx g dash x dx equals to fx gx minus integral f dash x g of x dx. Name it equation first. Let u of x equals to f of x. From equation first, if we put u of x equals to f of x, which implies that f dash of x is d by dx of u of x. Now if v of x equals to g dash x, which implies that actually this g dash is d by dx of g of x. So by definition of indefinite integral, integral v of x d of x equals to g of x. So put f dash, f, g dash and g in equation first. We get in LHS we get integral of u of x v of x into with respect to d of x equals to, now f of x is u of x, g of x is integral v of x minus integral of f dash is d by dx of u of x into g of x is integral v of x dx whole dx. So this rule integral ux vx dx equals to u of x integral v of x minus integral differentiation of u of x into integral of v of x d of x. This rule is called as the product rule of integration. So product rule of integration means we have to integrate, or we integrate the two functions which are in product, and their integral is first function into integral of second minus integral of differentiation of first into integral of second function. This rule is applicable. This means that this product rule is applicable to any form of functions. We know that the simple multiplication of two functions is commutative. That is, if we have two functions f and g, then fx into g of x, that is simple multiplication. It is not composition of two functions. It is simple pointwise multiplication is commutative. That is, fx g into g of x equals to g of x into f of x. So this means that integral fx gx equals to integral g of x d of integral g of x into f of x. But in order to solve this integral, which is product of two functions, we have to order f and g we cannot take f and g with any order. That is, there is a restriction while giving order to this f and g in the product of this integral. So this restriction is given by the rule which is called as the ILATE. That is, we arrange the functions f and g in the product of this integral as in terms of ILATE. Here ILATE means I means inverse trigonometric function. So this means that whenever we have the product containing one inverse trigonometric function, we have to take this inverse trigonometric function as the first function. Now if L means logarithmic function, now if the product contains a logarithmic function, so this means that we have to arrange, or we have to order that logarithmic function according to this. A means algebraic function like x square plus 1. T means trigonometric function like sin x, tan x, cos x, and E is exponential function like ax, e of x. So if we have integral fx gx equals to log x sin x, here first function in given integral is log and second one is trigonometric function. But in isolate, L comes first and T comes later. So this means that this is the required order. So this means that we have to take L log x as first function, which is actually the first function, and sin x as this second function. But if we consider, this sin x log x, sin x into log x, then we have to arrange log x as first and sin x as second function according to isolate. Similarly, if we consider e of integral e of x into sin of x, here first function is exponential and second function is trigonometric. But in isolate, t comes first and exponential comes later, which implies that in order to solve this e of x sin x integral, we have to arrange these two functions as integral sin x into e of x. But in some cases, that is in product of two functions, if we have to solve that product of two functions, we can take those two functions with any order. That is, it does not alter whether we will take f as first function or g as second function. But in some cases, or in general, in integrals with, we cannot take the functions with any order. So simply we should arrange those two functions according to isolate. Like if we have to solve this integral log x, how to solve log x, we should take log x as log x into 1, because log x into 1 is log x. So there we have two functions, one is log, second one is this identity, which implies that logarithmic and x in this algebraic function. So we have to take fx as log x, because in isolate log comes first, algebraic comes second. This means that their product, according to product rule of integration, it is first function, that is log x, into integral second function minus integral of differentiation of first, that is 1 upon x, into integral of second, that is 1 dx whole dx, which is log x into x, because integral of 1 is x, minus 1 upon x, integral of 1 is x, so it is simply x log x minus integral x, which is x log x minus x plus c. So simply taking x common, it is x into log x minus 1, which implies that integral of log x according to this product rule of integration is x into log x minus 1. Similarly, we can find the indefinite integrals of inverse trigonometric functions by this, that is by product rule of integration. Like if we have to find, or if we have to solve this integral sin inverse x, then the sin inverse can be written as sin inverse x into 1. We know that in isolate I comes first, that is inverse trigonometry comes first, and 1 is algebraic function, it comes later. So this means that we have to take sin inverse x as first function, 1 as second function. Using product rule of integration, it is sin inverse x first function into integral of second function, that is integral 1 dx minus integral of differentiation of first into integral of second into whole dx, because we have to integrate this whole term, which is simply integration, this differentiation of sin inverse is 1 upon root 1 minus x square, and integral of 1 is x, so x upon root 1 minus x square. So put this x sin inverse x minus I, where I is this integral x upon root 1 minus x square, put 1 minus x square is t, which implies that x dx is minus 1 upon 2 dt, which implies that I becomes minus 1 by 2 dt upon root t. After integrating this using x raised to power n rule, we simply get minus root t, that is minus root 1 minus x square, which implies that substituting in this equation, integral sin inverse x dx is x sin inverse x minus integral x upon 1 minus x root 1 minus x square is minus root 1 minus x square, which is plus root 1 minus x square. So this means that sin inverse x, its integration is x sin inverse x plus root 1 minus x square. Similarly, we can solve this integral sin, cos inverse, tan inverse, cosec inverse, cot and sec inverse by taking second function as 1 and using the product rule of integration. So thank you.